Alright, today I'll talk about the problem home on the range. So in this problem, we will use dynamic programming to keep track of the optimal side lengths for each of these grid, which is the maximum side lengths for each of these grid. And we will store them in a map, so we will keep all the things in order. And so when we receive the input, we'll first check if this current grid is 1 or not. If it's 0, then that means we cannot have we cannot have a square from this grid as the bottom right corner. So we will, if this is 1, we will get the minimum of these 3 side lengths. This is the side length on the top left of this grid. This is the side length on the top of the grid, and this is the side length on the left of the grid. And so when we get the minimum one, we will have the one that will be the smallest square side length, but also it will. So we will do this to make sure that there are no other blocks blocking, like other zeros blocking the whole square. And the smallest one will represent the maximum side length that we can get for this current grid. And so we'll increase that side length by 1 since we have just written a new square. And now since this will keep track of the maximum length, but every time when you have a new square formed, then you can also know that the other squares with lower side length from 2 all the way to this current side length that we just got, all of these have to be increased by 1 because there can be a smaller square inside the bigger square. And so this program is actually really simple. And at the end, you can just loop through all of the map, since the map will only keep track of the ones that are greater than equal to 1. And the map will automatically keep all these things sorted, so you can print out each of these and you can stop the program afterwards.